recreate the user fresh, user add D, home 1, student 1, the name of the user student 1. Since we're on a remote server here, it's part of the confusion when you set up users or interact with Linux systems in a shell environment. You never really know where you are on the system unless you pay attention to the prompt. I am root at Linux CBT Serv 4 as opposed to Linux CBT Serv 1, which is the host system. So let's take a look at what's currently set up. If we lsltr home 1, we'll see that the user add process has created a student1 directory in the home 1, and as you can see, we threw it off. Let's user del help. We threw it off. We indicated student1. We'll remove the items for student1. And now let's lsltr home 1, and it's gone. You may be wondering, how did it resolve student1 to student1 without a T? Because of the etc password entry. Now let's recreate the user. So we'll user add home student1, home 1 student1 for student1. And now when we lsltr home 1, we see the directory has been created by the user add process. In it, we'll find, if we turn on the hidden option, bash files, which are copied automatically from etc skel. And we'll lsltr etc skel with the A option turned on, not cat. These are the options that are copied automatically into the user's home directory. Now if we use user mod to move the user's home directory, let's say to home student1, then that would work as well. So for example, user mod home student1, move student1. This takes care of moving the user out of home 1 into home, just like that. And now we can move the user back if we'd like. So it's user mod D home 1 student1. Now the user will be moved out of home into home 1. So using user mod, you can move the user's tree and preserve permissions about the various mount points. So now we have storage. This user differs because this user will be parked at the home 1 mount point. But we've yet to do one important thing, and that is to set up the home 1 mount point so that when the system reboots, it's auto-mounted. So the fifth step, aside from all the playing around we've been doing with user mod and user del, user add, is to configure /home1 to auto-mount when the system boots into various run levels. To do so, we'll nano etcfs tab and copy the home entry and modify. So we'll copy and modify the home entry to suit our needs. And that's the /home entry, of course. Let's take a look from our shell. We'll reset the buffer and then nano etcfs tab, our file system table file. Here's a label for home. We want to duplicate this, so we'll just Control K and Control U twice, and the new label will be for home 1. We'll bring this back up, keep everything on the same line, otherwise you'll have problems booting, or at least have problems at that point when the file system attempts to boot. And don't forget, like we did earlier, if you want quota support, now's your opportunity, turn it on. So we'll indicate user quota as well as group quota support, just in case. And bring everything back onto one line. So now home 1 will be automatically mounted whenever the system boots. And ditto for the home partition. If you want to enable or impose limitations on home as well, just go ahead and update it with user quota and group quota support. So let's indicate user quota, comma group quota support. Now both file systems will be able to support quotas. So now we've set up our file system to properly mount whenever we reboot the system. And since this is a remote system, we can reboot it and then check in with it to determine whether or not it's actually worked. Now there are additional utilities that you may use, GUI as well as TEX. For example, if parted is installed, this is another utility. Parted can be used to automatically create file system partitions. When you execute parted, you indicate a partition, otherwise it defaults to no partition. You execute help, and then you'll see how to set as well as select a given device. You can also print to display a partitions table, but we're not in a partition, so you'd have to select it. So select, for example, dev SDB, and then print dev SDB's table, where you'll see the lone partition, the fact that it starts here and ends here, and that it's primary and ext3. So this is yet another utility that can be used. Parted also has a unique ability to allow you to assign a file system, ext2 or 3, from within its interface. It automatically takes care of it for you. So this is another tool that's useful that will allow you to manipulate partitions relatively easily. Now at this stage, what we should do is reboot the remote system. It's currently in row level number 3. We should reboot it and then confirm that the file system has been brought up for us. Now while it's being rebooted, we'll recap the steps required to create a partition, an ext3 or 2-based partition. They include the fact that you need to identify available storage. So you use fdisk-l, or you may use parted with the appropriate partition. fdisk-l tells you what's available, what's connected, and what's available. You can tell what's available because even on our local system, for example, let's find a root shell, just to recap that process. We use this third shell over here, and it's been closed, so we'll SU in. So even on a local system, when we execute fdisk-l, it tells you the connected hard drives. It also tells you the total number of cylinders, 16,065. So all you need to do, or in this case 4,863, this is the multiplication, the value of each cylinder, so 4,863. So all you need to do is look at the layout of the partitions to see whether or not any of the partitions make it up to the end or the last cylinder, or close to the last cylinder. In the case of this computer, yes, 14 to 4863 represents an LVM volume. So in this regard, we can't create any additional file systems. However, in the case of the system, the remote system that we rebooted, it had a spare hard drive. So we were able to lay out file systems on that spare hard drive. It also had space on the primary hard drive. This system's booked. There's no space, but the remote system has space. So you need to identify storage. Use fdisk to do that. Then you create partitions using fdisk, followed by the hard drive that you'd like to operate on. If it's primary, you indicate primary, but you always indicate M to indicate that you'd like to add a new partition. If you'd like to delete a partition, then just press D and you'll delete it. You determine the start cylinder. For the subsequent partition that we'll create for swap, we'll start where the cylinder is free, so at the first free cylinder, and then increment it to the size of the swap that we'd like to allocate. Save the changes using write. We didn't indicate that, so step F, W, to write the changes to the disk. And if there are problems syncing the disk, then use part probe and the partition. In the case of the partition we recently set up, that would be dev SDB1. That forces a write to the hard drive's partition table on a running system. Worst case scenario, if it doesn't work, reboot your system and it will work. You then create a file system using make2fs or riserfs, make-riserfs. You create the file system for ext3, use lowercase j, followed by the partition number, beneath the dev tree, of course. Once you've created the file system, you're free to make a directory and mount it. Once you've proven that you can write to it, interact with it, and all looks well, update your etcfs tab so that when the system reboots, the mount point is available automatically. And that's really all there is to provisioning a simple ext3 or 2 file system. If you wanted ext2, which means ext3 or ext2 meaning no journaling, then drop this lowercase j option. that'll create an ext2 file system instead of an ext3 file system. And by now the file system should be up, so let's reconnect. And there it's prompting us. We'll df-h, and there you see home 1. System has been up for 3 minutes. So home 1's mounted, and that means the data are accessible. Now, if you encounter problems remounting using a label, consider changing your label to the dev location, such as dev sdb1, in your etcfs tab file. So, for example, let's nano etcfs tab. We've got label home 1. Sometimes the kernel throws an error because it's unable to find a disk with a label. So unless it's labeled home 1, it might give an error when you boot. So change this. In our case, it hasn't given an error, but change this to dev sdb1, and you should have no problem mounting it. And just ensure that your syntax is proper for user and group quota, and the file system will come up whenever you boot your system. So that's a basic ext3 file system. Next, we'll focus on swap file systems.